Okay. So I already introduced myself earlier. I'm Tim Sutton. I'm one of the developers of QGIS, which is I'm going to tell you about just now, and also one of the developers of InnoSafe. I'm going to tell you about 4 things today. One is about PyQt. I'm going to tell you about QGIS. I'm going to tell you about InnoSafe, and I'm going to tell you some of the nice lessons we learned when it comes to Python coding that we've learned from while we were working on InnoSafe, and just in general. So the first thing I want to show you is PyQt 4. Has anybody heard of Qt?
Yes.
Yes. Yes.
Okay. Do you know that it has Python bindings?
Yes.
Yeah. I don't need to introduce it too much, but it's a very exciting programming toolkit because it runs on just about every platform. It's been ported to Android, Linux, Windows, OS X, and a lot of small like embedded operating systems and other things like that. And it's the basis for a lot of big projects like KDE Desktop uses it, Google Earth uses it, and of course QGIS uses it. And what's nice about it is it has Python bindings, so you can program Qt in Python and make very nice user interfaces. So with a few lines of code, you can write something like, you have to have a Hello World application always. So to write a Hello World application in Qt, you do something like create a new application instance, and then create a label, set as text, and then show the label, and then execute your application. And then you get something like that will pop up. You get a Hello World application. So Qt provides different levels of functionality in this library. So it provides some graphical user interface components, provides a networking library, so you can do like fetch a URL or push some information over the network. It provides XML, so it's got an XML parser, it can do DOM manipulation. And it's got a lot of file and I/O libraries. So a lot of it is duplicating what you have in Python already, because Python has all these things as well, except really it doesn't have a standard graphical user interface library. There's Python, Tickle, but it's not really part of the standard Python. Does it come standard part of
WX Python.
It doesn't ship with the Python core, though, does it? Is it
Tinker, right? Yes.
I think the Tickle one is. Does it ship with the Python core? And Tickle was always for me the most ugly graphical user interface tool. That they've improved it a bit now. But so in many ways, it's doing what you can do in Python. And so you have to choose which parts of Python you want to use and which parts of Qt you want to use. You can make more complicated applications by just creating widgets, like this is a widget, and this is a widget, and putting them together into a layout, and then combining them, and then making it do things. So in this case, I've created a vertical box layout, and I'm setting the layout to a widget, and then I'm adding a push button, I'm adding a label. And then what's really nice about the Qt framework is it's got this idea of signals and slots, which is a callback mechanism. So when you want to have asynchronous events happening, you can say, when I click this button, then go off and handle that event. And there's an event loop that runs in Qt. The event loop is listening for different events, and then it dispatches them to the right function. So in this case, when I click on this button here, this callback, this slot is called, and this slot's going to change the text of the label to Hello World, just by clicking on that. And it's very little programming you need to do in order to get that in place. Actually, this way of programming with Qt is not the normal way of doing things. Well, I don't like this because actually you can do all of this using a graphical user interface designer. So there's a tool that comes with Qt called Qt Designer. And instead of writing all that code about creating layouts and adding widgets to the layout and so on, you can actually design your layout in a graphical designer and then you can connect things up. I'll just quickly demonstrate how that works. Oops. So I'll just make a new form. So you have something like this, which is an empty dialog, and then you get a panel of tools. Define it because my screen has gone a bit small. So you have this this list of different things that you can add on to a dialog. And what's really nice is that you can, without doing any programming, you can actually create interactions between these. So I'll give you a quick example of that. So if I, for example, have a layout, a slider. Let me find this slider. There we go. Right. So if I have this one, and I want to have maybe a data entry box for a number, I can actually connect these two together without doing any programming and make them behave so that they are linked to each other. So this slider has some properties here. So let's see, it's got a minimum and a maximum of 0 and 99. And this spin box also has some properties, a minimum and a maximum of 0 and 99. And I want to make them, to link them to each other. And so I can use this tool over here. And just by dragging and dropping like this, I can say these two things must be connected. And then I can say, when I finish changing the value on the spin box, I want the slider to update. So I choose value changed on the spin box and set value. So this one, when the value changes in this one, then it will call set value on that one. And then I can do the reverse as well. So I can say, drag that one to that one. And I say when the slider moves, then set the value on the spin box. Okay, and then go back to normal mode. So you have to switch to the signal slot editor mode to see that. Now you can't really see that they're there, but you can do a preview of the dialog like this. And you can see the two things are linked together, and I didn't write any line of code. So you've got a really powerful way to design user interfaces and have interactions between things. And so that same application that I showed you before, I could redesign by just creating a dialog and putting a button and a label on it. And then one of the things is when you create this dialog, it creates this thing called a UI file, which is just an XML file describing the different buttons and widgets that you've placed onto the dialog. And then you can turn that UI file into Python code by running something called the Python UI compiler. Okay, which is going to parse this UI file and turn it into some Python code. And what you get out is something called, I'll call it dialog base, for example. And that Python code contains a Python class implementation. And I usually use that as a base class. And then you overload the class, so you inherit from that class in your own code. And then your application becomes something much simpler. So can you remember the previous example I showed you? I had so much code with just creating widgets and so on. Now all I do is I inherit from my UI file, and then I just call its constructor in my constructor, and then I show myself. And so I've got rid of a lot of code just by drag and drop designing my graphical user interface. And this makes it a really powerful way to build graphical user interfaces, because you don't need to write everything by hand. You can have somebody who actually is good at design. Usually programmers are not good at design, so you can have somebody who's like...
One cannot be trusted with anything.
So you can have somebody who knows what good looking means, can go there and make it look nice, and then you can focus on the application logic, and somebody else can focus on the user experience. And this is the basis for writing all of the extensions and things that we do in QGIS with Python plugins, which I'll show you in a minute. Yeah. You will notice that if you have a Q application, instead of just calling main as a normal Python application, we call this Q application. And what this thing does is it starts the event loop. The event loop is this thing that's running in the background in its own thread, listening for events between signals and slots, and calling the right methods when they're called, and also just making sure that the user interface is responsive. So it's running in its own thread in the background. So that's Qt, what I showed you now. So QGIS is an application that's written in Qt. In fact, we wrote it mainly in C++. And then when we did the version 1 release of QGIS, which was about 4 to 5 years ago, we launched Python bindings for QGIS. And we used something called SIP. I don't know if you've heard of SIP before. It's basically... what is the other tool that's often used for creating Python bindings? Swig. Has anybody heard of Swig? Okay, so SIP is kind of doing something like Swig, but it's Python specific. Swig you can write bindings for many languages, and SIP you write Python bindings only with it. And what it does is basically it creates an API which matches the C++ API, but it's in Python. So somebody added SIP support or SIP implementation to QGIS, and now we can program QGIS in Python as well. So what is QGIS? It's a geographical information system. So that means you can use it to open, visualize, symbolize, analyze geospatial information. And it's completely free and open source software, so it's released under the GPL version 2 license. The project's 11 years old. When we started, there wasn't a version 3 license yet. And it's allowing you to do basically what you're doing in ArcGIS, or if you're a GIS user, or if you haven't ever heard of GIS before, if you think of something like Google Earth, it's giving you something similar to Google Earth, except it's not a three-dimensional environment. You have a flat map, and it's really focused on letting you build your own maps rather than just taking the one that Google's delivered to you. So this is what the application looks like. I'll show you it in practice in a minute. But basically, you have some idea of you've got toolbars, and you've got normally a map in the middle, and you've got a legend with the different layers. Again, if you've used something like Google Earth, it's quite familiar. And then you can turn layers on and off, and you can zoom around in the map, zoom in, zoom out. And you can also look at the properties of things. So I've highlighted this street here. This is my hometown back in South Africa. And this street here I've highlighted, and then I've opened this thing called the attribute table, which is a database behind every layer. And I can see the information relating to that street. I can see what the name of the street is, or how long the street is. Whatever information I want to store for this layer, I can store there. So so this is QGIS running. I just need to get the window size. I'm going to show you Intersafe in a second, so I'll just hide that away for now. So this is, I wonder where this is. Oh wait, oh no, that's Jakarta. And this is a map with some flooding information from 2007. And you can see I can zoom in and out into the map. And I can add different layers onto the map. So in a GIS, you've got this concept of vector layers, which are made up of points, lines, or polygons. And you've got a concept of raster layers, which is basically a picture that you can put onto the map. And then the really nice thing is that in a GIS and in quantum GIS, you can create your own data. So I can say new shapefile layer. And I can give it some properties. Let's just make some lines like this. Now you'll see there's a new layer being added to my map. And then I can actually change the information on that layer by, for example, drawing a line like this, giving it some details. And then you can also change the way that layer looks. So I can go there and choose some symbol for it, or I can design my own symbol. And then you can save your changes. So it basically gives you an editable map that you can change the look of the map and you can put your own information into it. You can do many, many other things with QGIS. Obviously, in 45 minutes, I could probably only show you one feature of QGIS and spend the whole 45 minutes about it on that. So, but what's interesting is that under the hood, QGIS is built with Qt 4, which is the toolkit that I was showing you at the beginning of this talk. And we've got the PyQt bindings, so that means we can program and extend QGIS in Python. And QGIS is made up of different parts. So it's got the core library. The core library is all the non-graphical user interface parts. It's the things that let you deal with opening data sets, saving data sets, doing geospatial analysis, and so on. And then we've got the GUI library, which has got more graphical user interface elements in it. So anything that's reusable. So if we've got a dialogue that's used in multiple places within QGIS, then we would have that in our library, and then you can reuse that yourself. And then we've got the application itself, which is sort of using these two libraries in order to bring you a graphical user interface. So the application is something that we deliver as an installer. There's a Mac package, a Mac bundle for it. There's if you use Linux, there's you can apt-get install QGIS. If you use Windows, we've got a standalone installer for it. And that bundles these two things. But you could also just take, for example, this one, and then write some back-end code. So if you want to put something on a server or just do some analysis that doesn't need a graphical user interface, you can use these libraries to write your own applications. I'm going to show you a little bit about that in a minute. And so the nice thing is also we've got these Python bindings for Pythonistas. So that means that we can do all kinds of nice things in the application. So if you go into the application, you'll see that we have this Python console here. The screen is a little light, but you can basically type any Python in here and manipulate QGIS. So I'll show you some examples. I want to cut and paste a bit. So what I'm doing in this example is I'm going to I think it doesn't let me. I have to use the new version of QGIS to paste it all in one go. Let me just do again. This is the development version of QGIS. We've spent a lot of effort on the Python support in the development version, which is going to be released as QGIS 2 very soon. So I'm just switching to the development version because the Python console is much nicer here. So I just need to add a couple of layers here. So I've got some layer here. And with the new Python console in QGIS 2, it supports syntax completion, so I can say something like, you see you get this pop-up showing you the API. And you can also, it's like cut and paste blocks of code in which you couldn't do before. So that's what I was trying to do just now. I'll just show you on my slide because I'm going to get sidetracked otherwise. But basically what I'm doing is I'm asking this thing is called the map canvas, and I'm getting its extent, and then I can say split the extent. The extent is basically the top left and bottom right corners and geographical coordinates of the map. I can ask it to split it and do some normal manipulation of that. It comes back as a list, or I can create it into a list, and then I make some text, and then I can use the Qt API to display a message. So I've created a Q message box, and I'm displaying the Q message box in QGIS there. So right from inside of QGIS, I can program using Qt and make it do things. So what can you do with the QGIS Python API? You can do almost anything. You can change the application. You can create plugins for QGIS. You can create standalone applications that are based on the QGIS library. So, for example, we did one once for the schools in Alaska, where they wanted a special browser of geospatial information to give to the students, but they didn't want to give them all the buttons and all the functionality. They wanted to make it really simple and have all their data sets preloaded and pre-prepared. So we made like a new user interface for QGIS and with the QGIS API. And many people have created a whole lot of different kinds of tools and applications based on the QGIS API. And the most interesting part probably for you is if you want to do anything that has some geospatial element to it, is that you can create these things called Python plugins for QGIS. And the plugins are distributed via a Python plugin repository. So if you've used like an App Store on Mac or apt-get in Linux, it's the same idea. You create your plugin and you post it into this central repository, and then other people can discover and install your plugin and load it into QGIS. So you've got a distribution mechanism that you can share your plugin to other people. So you can do all sorts of fun things, like let me try to do this one, see if it will play along. So I can take, for example, because it's all written in Qt, I can actually get the main window class. So what I'm doing here is I'm saying this iFace thing is an interface object, which is basically the hook that you get from Python into the QGIS application. And the iFace is provided to you by the QGIS API. So whenever when you write a plugin, the plugin loader in QGIS passes this iFace object over to your plugin, and that's basically, you can use that object to then manipulate QGIS. So I asked the iFace for the main window, which is the whole window of QGIS, and then I use this find children, because the way that Qt works is the user interface is actually a tree. You can think of it like a DOM model in a web page, but so you can have a main window, and then inside the main window you've got toolbars, and inside toolbars you've got tools, and everything is, you can think of it as a hierarchical tree. And you can use something similar to the DOM in a web page to actually find different elements. So what I'm saying is find me all the toolbars in QGIS, so this, and up the top there. And then I can actually say, I can write a little loop. I'll just write it as quicker. And then when I press enter, all the toolbars disappear. And then if I want to get them back again, I can get them back again. And I can basically manipulate the whole user interface just by finding things in the application tree and then getting those objects. And then we have more formal ways of getting things as well. So, for example, the layers that are loaded, they're provided in a singleton class called the map layer registry. And the singleton class, the layer registry is basically every time I load a layer, it gets added to this registry, and I can query the registry for its layers and turn layers on and off, or remove them, or add them to the registry, and so on.
When you say if main window, does it return Q main window instance or?
Yes. Yeah.
Directly?
Directly. So I can also use the API to load layers. So in this example, I've got this satellite image, and it's on my file system as temp Landsat. It's a TIFF file. In the GIS, we use, you may be familiar with TIFF as an image format, but we use something called a GeoTIFF, which inside of this TIFF file, it's got metadata which stores where the corners of the image are on Earth and what the coordinate reference system is that's used for this data set. But otherwise, it's just like any other image. So I'm telling it where this image is, and then I can create a new QGIS raster layer. We namespace all our API with this QGIS in front. Qt has a registry of namespaces, so you could go there. In the very early days of Qt, you could get 2-letter. It's almost like a domain name. You could get a 2-letter prefix, and then they became more scarce, and then we were still quite early on, we could get a 3-letter prefix. So we put QGIS in front of all of our classes, and it's more of a C++ thing, I guess, that we, if somebody else implements a raster layer class, it won't conflict with ours because we have QGIS in front of it. So I give it the path to the file and the name that I want to show in the legend, and then I add it to this the registry that I mentioned earlier. It's a singleton, so the way that we get the singleton back is we ask it for its instance, and then we say add map layers, and I'm giving it just a list of one layer because I only want to add a single layer. And doing that will add the layer straight into QGIS. I can also use the API to create a standalone app. So I had a little post-it note here as well. Basically, I've got this layer with 3 points in it, and I might want to create an application that takes this layer and counts the number of points and just prints them out. But I don't want to even see a user interface or something. I just want some back-end code. That it could be, this could be a database that you've created with SQL Alchemy and Postgres or something like that, or Postgres, and you've stored your data in a back-end somewhere, and you want to have just some server-side thing that does some geospatial analysis and does something with the data. So I can create just a normal Python file, and I import from the QGIS libraries. So remember I said we have the core library, which is the non-GUI parts of QGIS. So I'm importing from the core, I'm importing our QGIS application class, which inherits from Q application, so it's a subclass of that. And then I'm importing vector layer and provider registry. Provider registry is another singleton class which keeps a list of all the different data providers we support. So QGIS has this concept that we're data source agnostic. We don't care what kind of data source you have. If you want to read in a data source that is new, you create a provider. You can think of it like a driver or a database driver. If you use Django, you